Okay, so now we're going to look at the proportionality theorem for triangles in the next part of the review. So if I look at the review here and I move it around, see it? I'm just kidding. Find the length of each stated segment. I'm going to move this a bit. Okay. Find the length of each stated segment. Now, when you see that these are parallel, this establishes corresponding angles, okay? First thing we know is that this guy and this guy are the same, and this guy and this guy are the same. If you remember when we had our little parallel line fun, we have two parallel lines, you've got corresponding angles, and when the lines are parallel, they're the same. So when we've got parallels in triangles, it means that the triangles are similar. So what this means, since I've got this parallel line, that triangle DEC, I'll write it here, is the same shape as the bigger triangle DBA. Okay, DEC and AB. Okay, they're the same. Now the proportionality theorem has, I'm going to designate this as X. Okay, proportionality theorem says that you can set up ratios to solve these triangles. Okay, now we're going to do it two different ways. So here's the first one. If I know these two are similar, what does that mean? DE matches up with DA, right? I'm sorry. Yeah. DE matches up with DA. So DE matches up with DA. So that means X over X plus 12, right? Because the small one would be X, the whole thing is X plus 12. On this side, we know that DC matches up with DB. So 7 over 13. Now if we cross multiply that and solve it, okay, if you can see my calculator here, if we cross multiply that and solve it, you're going to end up with 13x equals 7x plus 84. I'm going to subtract that 7x over. I'm doing this quickly, there's for a reason. 6x equals 84. And then you, I believe, get x equals 14. So x is 14. So the question is, that's a lot of work. Is there a quicker way we can do this? Well, I'm going to try this out and see if we can figure it out. When you have these two parallels, that creates the opportunity for the proportionality theorem. And this only works when you have the parallels. You've got the two similar triangles. How do I know these two triangles are similar? Well, do you see the corresponding angles? That guy and that guy are the same. That guy and that guy are the same, and they share this one. So two triangles, all three angles the same shape, right? Remember, similarity can be angle, angle, side, 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 or side, angle, side. Well, we've got the two angles here. Well, proportionality gives you a shortcut. If I've got the parallel lines, when you draw that parallel and create those triangles, that means that you can separate these into just pieces. X over 12 is going to give you the same thing as 7 over 6. Instead of having to do the little one over the big one and little over big, you can do piece over piece equals piece over piece. So now, look how many steps this is. 6x equals 84, x equals 14. A lot quicker, right? So let's apply the proportionality theorem for number 15 now that I've got your head spinning, okay? So, I've got my two parallels.
Mommy.
Honey, I'm working.
Can I have a Pop-Tart?
That's up to Daddy. So, I've got parallels, so I'm going to designate this as x. I can do piece over piece equals piece over piece because I've created the two similar triangles. So x over 38 equals 16 over 20. So if you look at this, piece over piece equals piece over piece. I don't have to do the long one like I did over here. I don't have to do x over x plus 38 equals 16 over 16 plus 20. I can just do the piece. So I'm going to cross multiply 20x equals 38, times 16, and again, I don't want to think, equals 608. I believe it's 608. 38, I'm just making sure I have it right, 16 over 20 equals x over 38. That is correct. And so when I do 608 divided by 20, and I'm going to get a decimal, I get 30.4. So x is 30.4. And you've again just used the proportionality theorem. That's what this is called, the proportionality. So let's do one more. Okay. Well, in this proportionality theorem, what do I have? Okay. There is nothing that tells me that these two are similar. Okay. So I've got this angle and this angle are the same. Does everybody see that? Okay, that angle and that angle are the same. EF and FG, do we know those are the same? Well, if one is x and one is x plus 2, unless x is 0, these two can't be the same. So that's not a median, so they're not the same size. But it tells us, it doesn't tell us that the two triangles are similar. Now, in this particular example, it should tell you that they are similar, but this one does not. Okay, so I'm going to create that for you. Reflexive property, they share the side, right? So now I've got an angle and a side. Now in reality, they should give you another angle. They should give you another angle. And so I'm going to give you this angle here, that those two are the same. So now I've got angle, angle. Okay, so those are proportional. Now, what that means is this one over this one equals this one over this one. Okay, or does it? What do you notice about these two triangles? Do you have a parallel like this one? You don't. This parallel establishes piece over piece. But if you look at this one, these are already full sides of triangles, right? If I'm looking at this is one triangle and this one is one triangle, I'm looking at two separate triangles, so I can go ahead and set up my proportions. So I can say 8 over 12 equals x over x plus 2. Now again, this was not provided enough information for you, so I went ahead and added it for you. You know how picky I am about information like that. So I've got 12x equals 8x plus 16, because remember you distribute. So when I subtract the 8x from both sides, again this is just algebra guys, 4x equals 16. I divide both sides by 4 and x is equal to 4. That means this side is 4 and this side is 6. And the scale factor would be 3/2. 6 over 4, 12 over 8. And again, they should have done a better job of indicating to you that that was a proportionality theorem. We use that basically with the parallels, but we didn't have a parallel here, but they also did not provide you with the angles that you needed, so I provided those. Okay, so let's look at number 17. Let's get into some word problems because you guys love word problems. Let me get this little calculator out of the way here. All right, so number 17 says if a 4 meter flagpole casts a 6 meter shadow at the same time, a nearby building casts a 24 meter shadow, how tall is the building? Okay, so this you really don't have to draw, but you can. All right, so if a 4 meter flagpole, I'll draw the flag because I'm artistic, casts a 6 meter shadow, that means it's a 90-degree angle. And we're going to assume that these are in the same time of day. How tall is the building? Here's your big building that casts a 24 meter shadow. Well, these are going to have the same angle because it's the same time of day. So they're going to be similar. So I'm going to do 24 over 6 is equal to this one over this one equals x over 4. Could you do it the other way? 6 over 24 equals 4 over x? Yes. But I like doing this sometimes because of the scale factor. So 6x, draw your butterfly, I neglected my butterflies, equals 96. You cross multiply 24 times 4, you divide by 6, and x is equal to 16. And if you want to check and make sure, 16 divided by 4 gives you a scale factor of 4, and 24 divided by 6 gives you a scale factor of 4. So we're looking at 10 minutes now. So let's look over at number 18. A rope from the tip of a flagpole reaches all the way down to the end of the flagpole's shadow, a distance of 10. So here we go. And the flagpole is going to be at 90. We always assume that. The length of the shadow is 6 meters. So here's the shadow. There's the rope. We'll put the coils there. That's the rope. There's the flagpole. The length of the shadow is 6 meters. How tall is the nearby football goal post if it has a shadow of 4 meters? Well, I want to know this, right? Well, if that's 6, okay, it says all the way down to the end of the flagpole, a distance of 10 meters. So the length of the shadow is 6 meters. The rope reaches down to 10 meters. The distance of the football goalpost is 4 meters. How tall is the football goalpost? You really don't even need the 10. That's a distractor. Remember we talked about distractors? Because I want to know, I want to know how tall this is. Actually, you do need it. Sorry, not a distractor. I was looking at the wrong picture. You actually do need the 10. Before I can do a comparison ratio, I have to know what this side is. Okay, I have 4 over 6, and that's going to equal to x over, I got to find that. Well, if I've got a right triangle, how do I find the missing side? Pythagorean Theorem. And so this one, since I've got c and b, would be 10 squared minus 6 squared equals b squared. Okay, and I'm not going to solve that out for you, but you could also recognize that this is a 6, 8, 10 triangle. Remember we talked about Pythagorean triples and you had a 3, 4, 5? 6, 8, 10. If you do it this way, 100 minus 36 is 64. 64 equals b squared. You square root it, and b is 8. So that's 8. So now I know 4 over 6 equals x over 8, and I can solve it. You have to use the Pythagorean theorem to find what's missing. So I've got 6x equals 32. And I divide by 6, and let's get the accurate decimal. So I'm going to do 32 divided by 6, and I'm going to get 5.3 meters. So the goalpost is 5.3 meters, which is very, very short. Okay? So we had to find this in order to find this, and we used Pythagorean theorem. Okay, what are we at right now? We're at 12 minutes. Okay, we got one more, and then I can close down this one. One more. Let me move this guy out of the way. And so Lindsay was checking out UT last week and has started to wonder how tall the tower was. Good job, Lindsay. She quickly took out her compact and placed it 102 feet from the base of the tower. So here's the UT tower. Okay. And she put out her compact 102 feet from the base of the tower, so that through the mirror she could see the top of the tower. If Lindsay is 6 feet, okay, there's the mirror. Lindsay is 6 feet, and she's standing 2 feet from the mirror. How tall is the tower? Okay, so the tower is this right here. All right. What we have here is we've got 2 similar triangles. And do you see how I've got these parallel lines? We can go back and use our proportionality theorem. Okay, since I've got a parallel and a parallel, 6 feet over how many feet for the tower, that guy over that guy, equals 2 feet over, but we got to be careful with proportionality here. 6 over x, I went from big to small, or small to big. I actually have to, in this case, use this one. I have to use the whole thing. And the reason is, this is not one of these pieces. It's the actual parallel portion. So 2 and 102 would give me 104. If I had this piece and this piece, then I could do that over that equals that over that, but I don't, so I can't. So I'm going to cross multiply and I'm going to get 2x, and I'm running out of equals 624. Divide by 2, so x equals 312. So the tower is 312 feet. And again, the reason I couldn't use the piece-piece proportionality is because that would be piece-piece and piece over piece. If you're given the actual parallel part, you have to go, this is the whole triangle over the whole triangle. So I have to go whole triangle over whole triangle. If you look back up at the top, do you notice how I have piece-piece, piece-piece? I wasn't given the parallels, was I? So that's why you can't use it. So the tower would be 312 feet.